Hiya, I'm Bella and I'm currently completing a Bachelor of Commerce and a Bachelor of Science conjoint degree. I'm currently second year and I love the environment.
Hi, I'm Freddie. I'm a fourth year student currently completing a graduate diploma in science, working towards becoming a secondary teacher.
Hi, I'm Natalya, and I'm currently in my third out of 4 years of a Bachelor of Science, majoring in both environmental science and physical geography. Our research question was, how does susceptibility to natural hazards such as earthquakes, flooding, and landslides change along the Kaiwharawhara stream catchment area? To answer this question, we gave the following hypotheses. Higher susceptibility for earthquake damage in Zealandia since it's lying directly above the Wellington fault line. Treslip Park will carry a higher risk of landsliding and flood damage. Higher damage to people and property, especially nearer to the Kaiwharawhara stream and the fault line. To test our hypotheses, we needed to generate a map for the Kaiwharawhara catchment and ground truth this was with examples of hazards in the field.
For landslide susceptibility, the literature focuses mostly on predictive models. These models usually include slope angle, rainfall, and vegetation cover as variables that affect landslide frequency and intensity. Other research has stated that smaller scale maps are best to get an accurate picture of susceptibility due to changes in parent material. This won't be an issue for us as we are using a smaller area. Due to the resources available to us, we use slope angle as our indicator of landslide susceptibility. In order to create our maps, we used ArcGIS. For this map, we imported digital elevation models, cropped that model to the Kaiwharawhara catchment with the clip raster tool, used information from Dello's study to find the criteria for slope angles, and then we labeled those three key slope boundaries with the spatial slope tool. After that, we generated the susceptibility map with measurement tools and a key.
It is explained by the Valoroso literature that there is a direct correlation between fault lines being present and the event of an earthquake. One is the causation of the other. This causes the decay of terrain and therefore introducing other risks as well. The study is backed up with literature by Cato and Benzion. To create the fault line hazard map, we did the following. First, we downloaded the map of the Wellington region and the relevant data such as the fault lines and the sea draining catchments in the region, including the Kaiwharawhara catchment. We then applied these datasets to the map using the raster tools. Finally, we ranked the risk of the fault lines in relation to the faults running through the catchment. You can see that there are 3 different areas that we have highlighted in relation to distance from the faults and the risk factors.
Pradhan explains the need for flood prediction maps, which allows for areas with high flood potential to be prepared. Due to the increase in high-profile flooding in the last decade or two, flood hazard maps have become an interest for many, particularly in the public, political, commercial, and scientific sectors. Sanson explains that to validate maps, they use the signs left behind by a flood instead of describing the actual event. Many tools of the ArcGIS system were used for the creation of the flood hazard map. Some of the tools used were the buffer and the raster calculator. The buffer tool was used to clip the rivers and flood hazards to the point where only relevant data within the catchment remained. The raster calculator was used to figure out where the river, buffer, and the flood hazards overlapped to help determine the potential level of risk of flooding. Before creating the final hazard map, we had to ensure that each map's values for determining hazard susceptibility could be overlaid, so that the end values would merge to create the final susceptibility levels. To combine all 3 maps, they were imported and layered together with the use of the raster calculator tool. Each layer had a raster cell value that, when combined, equaled a new number, which became our hazard susceptibility levels from 1 to 8.
To answer some of our questions on damage to people and property, we needed to overlay infrastructure onto the hazard map. We did this by using data from Wellington City Council on roading, the rail line, and buildings. This new map allowed us to see a high risk to rail, which ran along a 7 to 8 hazard ranked area, and also to buildings, which were generally in less risky areas, usually from a 2 to 6. When we went into the field to ground truth the hazard map, we needed to identify any hazards, note their ranking on the map, and then record their location. The first site we visited was Zealandia. We observed the following hazards there. For photos A and B, this was the Lower Reservoir Dam, which is at risk of flooding and overtopping from a landslide surge, and is also at risk for damage from earthquakes, which would cause a flood into the residential areas below. This area had a hazard rank of 7. For photo C, this was a view down the valley, which showed the steeper fault scarp to the west, which is on the left of the picture, and the shallower slope opposite, with more developed vegetation. For photos D and E, we had exposed rock faces along the walking path, which shows how fractured the rock is in this area, due to the extreme pressure of being less than 100 meters from the fault line. This had a hazard rank of 8. For photo F, that was the upper dam. Again, this had a risk of damage in an earthquake, flooding, and landslides. But this was a little bit less likely due to the lower water level behind this dam. This had a hazard rank of 8. Here's me showing how the rock was more fractured in Zealandia due to its proximity to the fault.
Check out all this crumbly rock. Wow, I wouldn't want to be under here in an earthquake.
The second site we visited was Otari Wilson's Bush. We observed the following hazards there. In photo A, there's the rocks, which were less fractured along the slopes. This was because they were further away from the fault line than they were at Zealandia, so there's less pressure on the bedrock. This had a hazard rank of 7. In photo B, that was the stream banks, which were well vegetated but still steep. There was a little bit of evidence of flooding along the banks where erosion had occurred as well. This had a hazard rank of 6. Photo C was the trees, which were along the western bank. These would be a hazard in a landslide or an earthquake if they fell, but also provided some slope stability. This had a hazard rank of 5. Photo D had a rock overhang next to the stream and the path. This would be hazardous to the public who are using the trail, but it's set well back from the flooding area, so it's unlikely to be shifted by floodwater. This had a hazard rank of 6. Photo E was rubbish in the riparian planting, which indicated the height of floodwaters from previous high rainfall events. This had a hazard ranking of 5. Photo F was the steeper banks as the valley got steeper downstream. The floodwaters would rise higher here than further upstream. This had a hazard rank of 6. Here's me chatting about rocks again.
Cool, so for this slope here, we're further away from the fault, so we've got less fracturing of the rock itself. It's coming apart in much bigger sections.
Our third and final site was Treslick Park, where we observed the following hazards. Photo A was a view of the Johnsonville train line. This was at high risk of landslide damage, although we are now further from the fault line. This was a hazard rank of 8. Photo B shows steeper banks to the right of the image with the track washed out. There was more debris in this area, such as logs and rubbish, indicating flooding frequency and height. This was a hazard rank of 7. Photo C shows the access to the bridge at Hanover Street. Again, there's lots of debris captured, which has a high flooding risk. Hazard rank of 7. Photo D shows a steep rock overhang with large fractures. Again, this is indicative of less intense pressure from the fault line. This was all hazardous for the public in case of a landslide. This had a hazard rank of 7. Photo E was a landslide on the stream bank, which is one of many we saw. This had a hazard rank of 8. And photo F had shown bank erosion from high water levels, which indicated that there were high floods and also potential for landslides. This had a hazard rank of 8. Our fieldwork helped us to come to the following conclusions. There was high damage risk in Zealandia by earthquakes due to the dam and the flooding this would cause. This supports our first hypothesis. Landslides were identified most in Treslick Park. This supported our second hypothesis. We did not directly observe much property damage. There was some in Treslick Park from floodwaters, partially supporting our third hypothesis. And our infrastructure map also showed the density of structures and transport routes along high hazard areas, which also supported our third hypothesis.
Our research project had some limitations that we came across. Our first was that we only sourced data from places that were of high risk on the map that we created. We are still unsure if there were also high risk areas outside of our map. Next time we would look at the outer areas of the map as well, including the urban areas. In some areas there were high levels of vegetation. This could have helped mitigate the risk of landslides and erosion, and in turn meant that landslides were not actually as high risk as we thought. With more time and resources, we could have looked more into this and accounted for the possibility of damage. The only areas that we looked at are the current hazards surrounding the high-risk areas along the Kaiwharawhara catchment. Next time we could look at the historical damage as well alongside the current condition of the terrain. We would love to thank all of the TAs and course coordinators that have helped us and organised all of the stations on the Zealandia trip. Our TA Matthew, who guided us on the Zealandia trip, and our wonderful group TA Katie. Katie has been such a big help and stayed with us every step of the way.